Hello again and welcome to Comprehensive Tutorials. In today's video, we will be looking at this keyword. We'll be seeing what it means and what we can do with it. Now, this keyword simply is, so this is what I'm talking about. I'm talking about this keyword. You can see that it's been highlighted to show that it's a keyword, right? So this keyword simply it's a pointer to the current object of the class we are working with, and we'll see what I mean in a bit. Now I went ahead to kind of write these comments over here so that we would know what is what, and I would encourage you to do same if you are doing this. So we would have our constructors at a particular place with a header method so that we can easily refer to them. Right, so what we did in the previous video was that we had a class vector, and then the class had attributes, public attributes, float and y, x and y components, and we had constructors to construct it, which accepts two attributes at the point of construction as such. And then after that, this allows us to create an object without passing in attributes, and later on do that. Then we had this method over here to print out the components. After we have done that, we had an overloaded operator to allow us to perform the addition on these objects. Now in today's video, we'll be looking at this keyword, and we've already talked about just a little on it a few minutes ago. So what I want us to do here is to have a second method. So this is a constructor we can already pass in. We can pass in the attribute already, but what I want us to do here is to have a method which allows us to set the attributes after we have constructed our object. So let's say that over here we come and then we construct an object called vector let's say vec3, right? So we have constructed an object without passing in any parameters, any attributes. Now what I want us to do is to say that vec3 dot, let's say, set attributes. To allow us to do so, then we'll pass in whatever attributes that we want to be the attribute of this particular vector as such. So this is what I want us to do. I want us to use this method over here, dot set attributes. So to be able to do that, I would want us to create a method over here, and it's not going to return anything. It's just going to set the attribute of the object that we are calling. So void set attribute, and what is this going to accept? We have seen over here that it's going to accept, say, float a. You're going to accept a float a, and then it's going to accept a float b as well. And then after we accept those ones, what do we want to do with them? We want to set them to the corresponding component of the object. But before we can do that, basically I want to link it with this keyword, so that's why I'm going through all this. So to do this, let's just create a pointer for the vector3 object, right? Because we have said that this keyword is the same as the pointer for the object we are working with, so that's where I'm building from. So we have this vector3 and I want to create a pointer for it. How do we go about it? We use the vector keyword with the asterisk. Let's say this is going to be called vec, let's say vec p1, let's say p3, because we're pointing to the third vector, so p3 is equal to the memory address of vec3 as such. So we have created a pointer for vector3, right? So when we come over here, we can then use the pointer to get these ones. So let's come up here, construct the full method, then we come down here and call it so we don't confuse ourselves. So we have a method over here, set attributes, and this is going to accept a pointer. Let's make it a constant one, so constant, and it's going to be a vector pointer, and this is going to, let's just name it p. You can name it anything you want, it doesn't really matter because it's just a parameter. So we have constant vector p, float a, float b. So these are the values we are accepting. What then do we do with them? We have looked at pointers to object addresses already, so we can say that we want to take the pointer and then we want to use the arrow operator, and we can see that this drop down list already gives us access to what we can select. So we want to say that the pointer, the x value of the pointer, right, we want to set it to be the a that we will be accepting, and then the y component, we want to set it to be b that we are accepting. Then let's just go ahead and see out the pointer is that. We would see why I'm doing that in a bit, because we're comparing it with this. So the pointer is, and we just see out p. Let me have a new line. Right, so now we have the set attribute method defined. So what we can do over here now is to have this object vect3 and set attribute. We want to pass a pointer to it, and then the pointer is vec p3, right, as such. And then let's run this to see what is going to happen. So we run this and we have an error here. It says that assignment of member vector x in read-only object. Right, so what we are doing over here is passing this pointer over here as a constant, and then we are getting in here and then reassigning it to a new value. Now the computer is saying that this is a read-only object. That means we can't modify it. So in the previous examples that we used constant to pass in those parameters, that meant that within their usage we couldn't modify them, we couldn't update them. And that's safe, because if you don't want your objects to be updated or changed, then you pass them as constants. But in this case, we want to reassign the pointer, the value over there, to a new value, a. So we clear the constant and then we run this again to see what is going to happen. And now we have the pointer is that. So vector3 was created, and then the pointer, the memory stack that was reserved is this particular address on the computer memory. Let's go ahead and then get the component of this using this component method to see if they have truly been assigned. So we want to use vector3 dot components, and we run this to see what the components are, and we have 6 7 over here as we have assigned. Right, so now we want to relate this to the this keyword. So when does the this keyword come? Now, as we have said that the this keyword is the same as the pointer for the current object that you are working with, so we can simply say that this, so in place of the pointer that we are accepting, the pointer of the object, we can just use the this keyword to tell the computer that we want the address of the current object. So this arrow x, and we are assigning that to a, and then this arrow y, we are assigning that to b. And then to see that they are the same, we want to output the pointer is dash end. So end, and this keyword is output this, and then a new line. So we want to output the pointer and we want to output this to see whether they are the same. So when we run this, the functionality is basically the same. So let's run this. I went through all this to show that this keyword is the same as the pointer. So the pointer is this, and this keyword is this. So, and you can see that they are the same addresses. So basically this keyword is the address of the current pointer, the current object that you're working with. Now let's go to the C++ website and see what they said concerning that. Now we can see that they have a different way of explaining it. So you can come over here and then check it out for yourself. And they have a second use over here as well. It's frequently used in operator equal member functions that return blah blah. So you can come over here as well and fiddle with the code. Now the next thing we'll be doing is what we call static members. Now one thing we needed to have noted at the operator overloading is that the sign over here does not really matter. Now we want to add the vectors, right? We want to add them. Great. So we get in here and say that the x component should be added and the y component should be added. But then what I want to drive across is that the sign over here does not really matter. So let's change this and see whether the functionality will change. So let's just change this to the division operator and change this to the division operator as well. But then when we get inside, our target is to add the vectors, but then we want to use any sign that we want. Then when we come down to call them, so we want to say that let me just clear this, or let me just comment them out. I don't know if we'll be speaking on them again. So we have, let's say, vector 1 and vector 2, and we want to add them. So let's just say that vector 3 is equal to vec 1 dividing vect 2, right? Then we go ahead and then output the components of vector 3. So let's run this and see what's going to be returned. Now we have 9 and 13. So we have 3 plus 6, which is 9, 5 plus 8, which is 13. So then what we want to drive across is that the operator that you use over here does not really matter, because it's legal. You can use division over here, but then you get inside and tell the computer that what you want to do with that particular operator is to add the components. So you are adding the components, but you are using the division operator. It is legal. But the confusion is, but it's confusing because it's universally known that this is the division operator. So it's advised that when you are overloading the division operator, you make it perform a functionality similar to its fundamental usage, other than opposing the usages, right? So this is legal, and you can go ahead and use this. Even minus operator over here is still going to work perfectly, right? So that's the thing I want you guys to note. And then the next thing is overloadable operators. Okay, yeah, so let's quickly go to the C++ website and then see what they are. So these are the overloadable operators that you have, the plus, minus, and all of these ones as well. So you can come over here, it's an exhaustive list, and just fiddle with them. Now the next thing we would be looking at is class array object. So let's say that we have a class called vector. Can we create arrays of that particular class? Because we had class of let's say we had class of ends, and we could create arrays of integers like this. So 6 objects, and it's going to take these things over here. We could have had a string, we could have had double, and of course we can have vectors because it's now a legal class. So we can have a class vector just like string, double, int. So let's say that we have a vector and we want to say this is going to be called vectors. And let me just use the array because it will sync in with that. So let's say vec array, right? And how many elements are we accepting? Let's just say 3, and then we go ahead and input those elements in there. Now let's input the first element, and it's going to be, let's say 2, 3, because that's what our elements are. The element is supposed to have an x as well as a y component. So when you are inputting your element, you want to do this because it's a vector class you are using. Great. Now we want to input our second one, let's say 5, 7, third one, let's say 3, 4. Right, so we have this array vector over here. Now what can we do with it? We can go ahead and access it. We can say vec array, and we want to access the second element, so index 1, because it's index 0, 1. Then after that, what do we want to do with it? You know that when we access this is an object of the class vector, and to see the components, we have dot component, and that will print the component for us. We could have even named the component as a sort of print statement. So let's even name this to void print, so that we get a feeling. So we have print, and we want to say print. dot print. Right, so this particular object dot print, let's run this to see what the output is going to be. Okay, so I have this open. I have to close it first. Now we have an error. Oops. Let me just clear this. We don't need it. So I'm rerunning this again, and we have an error here. It says that conversion from int to non-scalar type vector requested and all of that. Now we used parentheses here. Let's use curly brackets and see whether the functionality will change. So we are using curly brackets now, and let's run it to see what will happen. Again, an error here says that expected that order before vec array. Whoops, so we should have had semicolon over there. Sorry about that. So now we're running it. Hope for the last time. Great, so we are past compile time. And now we have an output 57 as such, because this is the second object of index 1. So we have 57 over there. Now we can't use parentheses over here. As you've seen, it threw an error, so we can use curly brackets. Take note of that. Right, so that is arrays in relation to user defined classes. So you can go ahead, just anything that you could do with integers, you can just try things out, just make concoctions and see what's going to happen. So right, that's it for this one that I wanted to just clarify some of these things. So class array objects, we've done that. Right, so the next thing we will be looking at is static members.